Lesson 6-1, Solving Systems by Graphing. This is our first look at a system of equations. It is just two equations similar to what we looked at in Chapter 5. And it looks like these two equations are written in standard form. The definition of a system of equations is two or more linear equations. So what we're going to do is, both of these are lines on a graph. So what's going to happen is eventually these two lines may or may not intersect. So what we're going to look for is an intersection point. So that's called a solution to a system. And it's going to be an ordered pair that satisfies all equations of the system. So the answer to this system is 1, 1. So if I plug that in, so I'm looking at this being the x value, this being the y value, so I'm plugging the x in here, the y in here. So I get 2 times 1 plus 1 equals 3. So this is 2 plus 1 more is 3. So that does satisfy this system, or this equation. If I try this coordinate in the second equation, I get 1 minus 2 times 1 equals negative 1. So if I simplify, I get 1 minus 2, and that is equal to negative 1. So that coordinate works in the second equation. So because the coordinate works in the first equation and the second equation, it is a solution to the system. So what I'm going to be showing you today is how to solve this system to find that intersection point by looking at graphs. So on the next slide, what we'll do is number 3 and number 4 first. I told you we were going to have a system and we were going to look at a graph to find the intersection point. So I'm just going to zoom in. So question 3, it says, use the graph to estimate the solution of the linear system. Check your solution algebraically. So if I go with this first equation being my line, if I were to graph that, I would want to find where their intersection points are. So just so that we can look at this top equation, if I solve this for y, I get y equals x plus 4. So I know that that line is this line, because it has a positive slope. The second line has a negative x as the slope. To move this x, I'd have to subtract it. So that's this line. But that was already figured out for us. So what we need to do is now look at that graph and figure out where do both lines intersect. Right here. So the coordinate of that point is forward 0 and up 4. Then it says check your solution algebraically. So if I put 0 in here and 4 here, negative 0 plus 4 is 4. 0 plus positive 4 is 4. So algebraically, our solution fits. So our answer to this system is 0, 4. Question number 4. Again, these two lines are already graphed for us. We're just trying to find the intersection point, so it looks like that happens right here. So our answer is forward 2, up 4. Notice this one has a scale of 2, so I move forward 2 and then up 2 boxes, but this is 2 and this is 4. So this will be our answer. If we check our answer, we're putting a 2 in for x and a 4 in for y, because this is our x value, this is our y value. So this gives us a 2. And down here, 2 times 2 is 4. 4 plus 4 more is 8. So it does check algebraically as well. Going back to number 1 and number 2, it says, decide whether each ordered pair is a solution to the linear system. So what we're going to do is we're going to rewrite this equation. Our x is going to be 4 and our y is going to be 1. So we're doing this without a graph. They're telling us if you were to graph these two lines, this is where they would intersect. So this is us checking our answer. So like I said, 4 goes in for x, 1 goes in for y. Do I get 3? Yes, I do. Bottom equation, 3 times 4 is 12, minus 1 does give me 11. Question number 2. We're doing the same thing. Top equation, plugging in negative 3 for x, negative 4 for y. So we have negative 4 times negative 3 is positive 12. Positive 12 minus 4 is 8. Checking the ordered pair for the second equation, 5 times negative 3 is negative 15, minus 3 times negative 4. So that was a negative 15, and then negative times negative will be plus 12, which does give us negative 3. So decide whether the ordered pair is a solution. Number 1 is yes, and number 2 is also yes. And our answers to 3 and 4 were 0, 4, and 2, 4. Please turn the page. So let's try a problem like you'll see in your homework today. It says, graph to solve the linear system. So we have two lines that we're going to graph, and we're looking for where they intersect. So the first line has a slope of 1 and a y-intercept of negative 2. So my intercept is what I want to graph first, and then I apply my slope. So my slope is 1, so that's up 1, forward 1, up 1, forward 1. And I'm going to do a couple of points in there. And then once you have 3 points, you should be able to use a ruler to connect your dots. Then the second equation has a slope of negative 1 and a b-value of positive 4. So when I graph, I'm going to intersect at 4, and then my slope is negative 1, positive 1. So that's going to be down, forward, down, forward, down, forward, down, forward. And then I use my straight edge to connect my dots. So again, I'm looking for the intersection point. Where do these two lines cross? And it looks like it's going to happen right here. So the answer to our system is forward 3, up 1. And our work is the two lines that we've drawn on the graph. Question number 6 is a little different. These two are written in standard form. And standard form of a line is going to look like this, where we have ax plus by equals c. So our a is negative 3, our b is 1, and our c is 10. So if you want to use this method to find your x and y intercepts, you can, but we're going to get some decimals in the bottom equation. Okay? So we're going to go back to our y equals mx plus b for some of these. So looking at the top equation, I'll graph that in green. If we cover up 2 times what is 6? 3, so that means our y-intercept is at 3. And then if I cover up my y value, x is equal to 6. So that's my x-intercept. So remember, from that previous chapter, to find our x-intercept, we plug 0 in for y. To find our y-intercept, we plug 0 in for x. So that's why I was covering up, because 2 times 0 is 0, so then x is equal to 6. And then you can go ahead and use your straight edge to connect your dots. In the second equation, when I cover up, I get a decimal. So we're going to practice putting it in y equals mx plus b form. So I'm going to add 3x, and I get y is equal to 3x plus 10. So graphically, I know that my intercept is at positive 10. My slope is 3 over 1. I can't go up 3 forward, so I'm going to go down 3 backwards. Down 3 backwards. Down 3 backwards. And it looks like I'm going to hit or intersect. Okay, so I'm looking for those two lines to cross, and that's going to happen at this red dot. So it looks like it's negative 2, positive 4. Going back up to this top equation, if you didn't want to do standard form with that, what you could do is just solve this for y. So my first move would be to have 2y equals negative x plus 6, where we would subtract the x. and then we would divide by 2, and we get negative 1/2 x plus 3. So notice we're starting at 3, and we're going down 1, forward 2, down 1, forward 2, down 1, forward 2, or up 1, back 2, and that's where our intersection point is. So what I'd like you to do now is pause the video, pass out the worksheets, and we'll do a couple of these together. Play the video once everyone has a worksheet. So here's what your worksheet looks like. We're going to do number 1 and number 3 together. So here's number 1. It says, solve a system by graphing. So we'll do the first equation. Taking a look at it, my slope is 3, which is equivalent to 3 over 1. My b value is negative 4. I think to myself, which number do I graph first? And of course, that's my b value. So my y-intercept is on my y-axis, so I'm going to go down 4. And now I'm going to apply my slope, positive 3, positive 1. So we rise up 3, forward 1, up 3, forward 1, up 3, forward 1. And then we're using our straight edge to connect our dots. And you could do your straight edge at the end if you wanted. Our second equation has an m of negative 3. So that's negative 3 over 1 or 3 over negative 1. We could use both of those slopes. My b value is positive 2, and that's the one we want to use first. So that's why I drew the star. So I'm going to go up 2. That's my y-intercept where it crosses the y-axis. Now I'm going to apply my slope. So if I do this first one that I had written down, that's going to take me down 3, forward 1, and it looks like I'm already touching. Down 3, forward 1, I'll just graph all 3 points for good measure. And then I'm looking to connect my dots. We're looking for our intersection point, so it looks like that happens right here. So our solution to the system is the coordinate 1, negative 1. We're trying to find where do those two graphs intersect. Jumping down to number 3. I wanted to try one with fractions in it, so let's do that top line. Looks like my b value is negative 2, and my slope is 5 over 4. So I'm going to graph my y-intercept first, and then I count up 5, forward 4. And it looks like I can only do 2 points on this graph, otherwise I'll be off the graph paper. My second line has a b value of negative 1, and my slope is also 5/4. So that means I'm graphing down here at negative 1, and I'm going to count up 5, forward 4. I don't see anything interesting yet, no intersection, so what I better do is connect my dots. And it's looking like my 2 lines are never going to touch because they are parallel. We've talked about that word before. Parallel means that their slopes are exactly the same. So if they never touch, they're never going to intersect. So there is no solution to this one. We will talk more about no solutions another day. There will not be any more like this on your worksheet. The last one I'd like to do, I believe, is on page 3. Notice how there's a new heading, and then we start over at number 1, 2, 3, 4. And I'd like to do question number 4. So the thing we have to remember to do this question is Hoy-Bucks. So we talked about Hoy-Bucks, where I see this y value, and that reminds me of Hoy. So this h tells me that this line is going to be horizontal. So horizontal means parallel with the horizon, so that means our line is down here where y equals negative 1. The second line has an m of negative 5/2 and a b value of 4. Again, we're trying to find the intersection. So I'm going to graph my intercept, and down 5, forward 2. And my next coordinate would be off the graph. So it looks like my intersection point can be located at +2, -1.